Alright, before we start talking about using the unit circle to find tangents of angles, I want to do a little bit of review and a little bit of practice looking for patterns in the unit circle that can help us come up with sine and cosine of the varying angles in the unit circle. So go ahead and draw it's kind of like our x-axis here, where we see 0, 2 pi, pi, and draw the vertical line as well that we commonly refer to as the y-axis. It doesn't necessarily have to be that, but a lot of times we kind of reference those as the x and y-axis on the unit circle. Go ahead and label those angles. So we have 0 right here. If you go all the way around the circle, it's 2 pi. We've got pi, pi over 2, and 3 pi over 2 right here. Remember, we can count this as 1 pi over 2, 2 pi over 2, 3 pi over 2, and then 4 pi over 2. Now, I want to look specifically at the pi over 4 angles, or multiples of pi over 4. So draw those out as well. So I'm going to color these. Let's color them blue. So they're about going to be halfway through here, and slicing this side in half. And so right here's our pi over 4. And every line I've got drawn here is a multiple of pi over 4. So we've got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. So let's just start off just by focusing on these today. And then that way we can see a couple of patterns here and some things that, I think very quickly, these, 8 angles we've got drawn here, you should be able to tell me the sine and cosine of those angles. To start off with, our black lines we've got drawn here, the ones we drew first, those should be fairly simple ones to come up with. And that's because if you think of this as the origin, and this unit circle has a radius of 1, then if you think about the ordered pair that would go right there, it's 1, 0. This would be 0, 1. Going this way, it'd be -1, 0. And right here, it'd be 0, -1. And so that should be something we can quickly think of when we, as long as we know where these 4 angles are, we should be able to come up with those ordered pair, and then we can quickly remember, or not quickly remember, but hopefully after enough practice, you remember that this is the cosine of that angle, this is the sine of the angle. And we'll discuss that further here in a moment. But you should be able to say, okay, I know that the cosine of 2 pi is 1, and the sine of 2 pi is 0. Same thing with 0. The sine of 0 is 0, the cosine of 0 is 1. So those should come quickly to you as you start to get more and more practice. Once again, I don't want you just memorizing the unit circle to draw it out. That's not our goal here, is to show that you can reproduce the unit circle on paper. The goal is for me to be able to say, what's the sine of pi? And you'd be able to tell me it's 0. Because you can close your eyes if you have to and think about where is pi on the unit circle, what's the ordered pair, oh, the vertical distance here is 0. And that's what we talked about last time in the video. That's what I want you to remember this time as well. The vertical distance going all the way around, that is your sine value. The horizontal distance is your cosine value. So right here, the horizontal distance is 1. Cosine of this angle right here is 1. The vertical distance, the amount you go up and down, is 0. So the sine there is 0. Up here at pi over 2, the vertical distance is 1. So the sine of pi over 2 is 1. The horizontal distance here is 0. You go left or right, none. So the cosine value of pi over 2 is 0. Same down below at 3 pi over 2. You go left or right, none. So the cosine value of 3 pi over 2 is the same. It's 0. But this time, the sine value, because you're going below the x-axis, is going to be -1. So those 4 right there should be quick ones for you to learn. But then, this is all review from the last video. I'm trying to shorten it up this time, because last time it was like an hour long. But just all review, and hopefully seeing it kind of just summed up will make a little more sense. We came up with this triangle last time, and the side lengths of those triangles was the square root of 2 over 2, square root of 2 over 2, and 1. And that checks out with the Pythagorean theorem if you try that out. And so this ordered pair is the same for the x and y. And this triangle stays the same all the way around the circle. But over here, notice our x value is negative. So that means the cosine is going to be negative. But the sine, the vertical distance, is still a positive square root of 2 over 2. Down below, notice they're both negative here. Just like when you graph on the Cartesian plane, quadrant 3, both x and y values are negative. Square root of 2 over 2. So the sine and cosine of 5 pi over 4 are both negative square root of 2 over 2. And right here, our x distance is positive, so our cosine's positive. And our sine is going to be negative. Now, some things we want to notice with our patterns here. Now, this is our equivalent of our 45-degree angles when we're talking about degrees, if you're still like thinking of degrees, which hopefully you're getting away from. But notice that all of these angles have 4 in the denominator. And so these are common angles we're talking about. If I give you something like what's 75 pi over 4, that's not a very common angle. But the common angles I'm going to be asking you about is usually less than 2 pi. And it's the ones that are on the unit circle. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4 all deal with this same triangle right here. And that is our square root of 2 over 2, square root of 2 over 2, and 1. So if I'm asking you for the sine or the cosine, it's different for tangent, but if I'm asking you for the sine or cosine of an angle, and you see that 4 in the denominator, most likely it's going to have to do something with one of these two right here, square root of 2 over 2, or negative square root of 2 over 2. Your job is to think about where's pi over 4, which quadrant, where's 3 pi over 4, which quadrant, where's 5 pi over 4, and where's 7 pi over 4. If you can picture that circle, I'm not talking about picturing the whole unit circle when I say imagine these things. Whoops, that circle's going off the grid. I'm saying if you think about a circle, and I say 3 pi over 4, this is how I think about it in my head. Well, I don't think of it in highlighters. Let me try to redraw this without a highlighter. I say, okay, here's pi. And I want to know where 3 pi over 4 is. You know, if I don't immediately know it from doing it over and over and over again, I just think, well, I want something over 4. Pi is the same thing as 4 pi over 4. Notice those cancel, you get just pi. So 3 pi over 4, where is it? Well, it's got to be just 1 pi over 4 short of 4 pi over 4, or right here. So your 1 pi over 4, which is the equivalent of 45 degrees, short of that, because it's 3 pi over 4. And now because I know I've got square root of 2 over 2, this is 1, pretend like that's the center of the circle. I got square root of 2 over 2 right here, but that's negative. This one's positive. So if I'm asking for the sine, I know it's going to be positive square root of 2 over 2. Asking for cosine of 3 pi over 4, it's going to be negative square root of 2 over 2. If I say 7 pi over 4, think about where that looks like without looking at the picture here. Where's 7 pi over 4? Well, I know that 2 pi is the same thing as 8 pi over 4. 7 pi over 4 is going to be 1 pi over 4 short of that. So right there, 7 pi over 4. So each time I don't go around and count 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and all that. I don't do that. I just kind of convert 2 pi or pi to the same denominator and think about it in terms of that. So later on we talk about, 11 pi over 6. You've got this circle going all the way around it. Here's 12 pi over 6. That's the same thing as 2 pi. 11 pi over 6 is right here, just shy of that. So that's how I want you to start thinking about it. Where would 5 pi over 6 be? Well, 6 pi over 6 is right here. That's the same thing as pi. 5 pi over 6 is going to be right there. And so if you start thinking about it in terms of that, comparing it to where pi is and where 2 pi is, then you can start figuring out where those angles are faster. And if you know the triangles, you can come up with the sine and the cosine of those angles. So right now I've just focused on these with 4 in the denominator because they all have the same triangle. And so it makes it super fast. If you know where 7 pi over 4 is, you know that this is positive square root of 2 over 2. That means the cosine is square root of 2 over 2 because it's the horizontal distance. And this is negative because it's going below the x-axis. It's going to be negative square root of 2 over 2. That's where we get this. And so your sine is going to be, sine of 7 pi over 4 is going to be negative square root of 2 over 2. All right? So that's just one small tip there just to kind of get you started with that. If we look at, let's see, let's draw our multiples of 30 degrees real fast. So I'm going to pause the video. You try drawing it out. Ignore the pi over 4 angles now, except for the horizontal vertical there. Draw it out and label it. So pause the video and do that. Alright, so I've taken that you've paused it and that you've got all of these angles I've got listed here labeled. All the green ones is also. But I'm going to go ahead and work through it with you just in case you didn't want to. You can skip ahead a little bit in the video if you've already got this down and you feel confident in it. But if you don't know, this is where I like to start off with. If you're not too familiar with doing all these, figure out that angle first. Now, remember in angles, that's our equivalent of 30 degrees. Pi over 2 is our equivalent of 90, so this is 1/3 of not quadrant 1, but of that 90 degrees. So 1/3 of pi over 2 is going to be pi over 6. This will be, and then we go around and count just by pi over 6. 1 pi over 6, 2 pi over 6, which same thing as pi over 3. 3 pi over 6, 4 pi over 6, which is 2 pi over 3. 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, or 4 pi over 3, 9 pi over 6, 10 pi over 6, which is 5 pi over 3, 11 pi over 6, and then 12 pi over 6. So let's look for some patterns here, some things that might help us see this a little bit better. Notice we've got 6 and 3 in the denominator now going around the circle. So right here's a 6, right here's a 6, here's a 6, and a 6 right there. Notice that they're the ones that are closer. It's a bad highlighter. They are closer to the x-axis. It's the pi over 3s that are further away. See how that one's kind of further? It's a larger angle. When we talk about it in degrees, it's the equivalent of our 60-degree angles, the ones with 3 in the denominator. Just so happens to be like that. Nothing special about 3 being in the denominator. It's just that it reduces to a 3 in the denominator. Something just to keep in mind when we're thinking about our triangles and how they look. It'll become a little bit more helpful when we're talking about tangent lines. So, not tangent lines, but tangent, the values of the tangents of the angles. So anyway, as we look at this, it goes all back to that one triangle we talked about that looks like this. And it's important to know the side lengths of those. Remember that this pi over 6, when we're talking about its ordered pair, if you go all the way over, it looks like we're about halfway up. So the y value there is 1/2. And then the x value is going to be square root of 3 over 2. And so now, looking at it like that, we can quickly fill out the rest of this. But remember, I want it so that you can say, what's the sine of 5 pi over 6? And you can visualize that and write it out. So we know sine, when you think sine on the unit circle, I want you to think vertical length. So here's 5 pi over 6. The vertical length there is what? It's 1/2. Therefore, the sine of 5 pi over 6 is equal to 1/2. Notice it's positive because it goes up. If I said the sine of 11 pi over 6, remember, vertical length there, or the y value. So the vertical distance right here is 1/2, but notice it's below the x-axis, so it's going to be negative 1/2. So the sine of 11 pi over 6 is negative 1/2. when we say the sine of 5 pi over 3. Sine of 5 pi over 3. You should be thinking, all right, where is 5 pi over 3 if you don't have this already drawn out for you? Well, I know that if I'm thinking about the unit circle, this would be like 3 pi over 3. And this right here would be, if we go all the way around, 6 pi over 3. Because that's the same thing as 2 pi. So 5 pi over 3 is going to be a little bit closer to the 6 pi over 3, so it's going to be right here. I know the ones with 3 in the denominator have this reference angle that's larger, because we've looked at our patterns here. It's kind of like thinking of 60 degrees short of 360. So it's this triangle right here I'm envisioning. So I know that the short side is right here. That's going to be the 1/2. And then the long side right here is going to be the square root of 3 over 2. But it's negative because it's below the x-axis. So the sine of 5 pi over 3 is negative square root of 3 over 2. What's the cosine of 5 pi over 3? Once again, same angle, but now the cosine is the horizontal distance, so it's going to be that 1/2 right there. Or if it helps you to see, maybe you're looking on a phone to see this drawn out like this. This is the 1/2. So cosine is horizontal distance. Cosine of that angle, 5 pi over 3, 1/2. Sine is this vertical distance, so it's going to be negative square root of 3 over 2. So this triangle shows up all over the place on these angles. And then, of course, these quadrantial angles going around, drawn the black lines, they're still the same ones that we had on the previous page here, written in red. So you can see that there. So that's pretty much it. That's the unit circle with the sines and cosine values. You can Google this. You Google unit circle and you can check all your ordered pairs if you're practicing. There are little tips and tricks that you see everywhere, little gimmicks that you can do. There's a thing called the hand trick to remember exactly where all these are. But I don't like you using that. I don't want you using that because it helps with quadrant 1. It doesn't help you with the others. I want you to become so familiar with this that just if I was to ask you what's 7 times 8, you can tell me the answer to that, like, off the top of your head. I want you to do the same thing here when I'm saying what's the sine of 2 pi over 3. I want you to think about where is 2 pi over 3? Well, it's got to be less than 3 pi over 3. So it's going to be up over here. The sine of it's going to be that vertical distance right here. If you can see it over here, it's this vertical distance right there. So it must be square root of 3 over 2 right there. And so you shouldn't be giving me on any of these angles, you shouldn't be giving me anything like square root of 2 over 2, because you know square root of 2 over 2 deals with only these angles over here. The ones with multiples of pi over 4. So when you've got something like a 3 or 6 in the denominator, I shouldn't see a square root of 2 over 2 for your answer there, whether it be negative or positive. So practice these out, because as you practice them, you're going to get better and better. And today we're going to add tangents to the mix, so the stuff builds pretty quickly. All right, part of the things I'm looking for in your notes as you go through this is that you're solving these types of problems too. This is just kind of a little bit of extra practice here. So you kind of did some of this on the mini quiz or the practice quiz I gave you last week. So try these out now. Okay, and this is how I want you to do. I'll do number 1 with you. I'm going to do all 6 with you. But before you pause the video, let's do number 1 together. So the sine is 7 pi over 6. So the first thing I want you to do is visualize the circle and where 7 pi over 6 is. Think about what triangle goes with it. Is it a triangle with it? Or is it on, pi or 2 pi or, somewhere in between there? So when you think about the circle that goes with it, you can even sketch it out if you want to. In fact, let's sketch it out in our notes. Let's see. Well, 7 pi over 6, is it bigger than pi? Well, yeah, because 6 pi over 6 is right here at pi. So it's 1 pi over 6 past it. So because I know it's not a 4 in the denominator, it can't be one of our 45-degree angles if you think about it in degrees. So it's our triangle that looks like this. And it's just past it, so it's not a pi over 3 angle, which would be down here. And so this is going to be, what's sine go with? Vertical or horizontal? Sine goes with the vertical. So it's going to be 1/2, but it's going to be a negative 1/2 because it's below the x-axis. So our answer here is going to be -1/2. So this is what I'm looking for in your notes. Draw each circle, and you don't have to draw each triangle, but just tell me what the answer is then. So pause the video, try those out. So pi/3. If I draw my circle right here, notice pi/3 is less than pi. It's 1/3 of pi. So you can think of it like that if you don't have it memorized. Like if I divide this up into thirds, this is pi. Pi divided by 3 is going to be right here. Now, when we did it right here, we said here's pi/6. That's 1 pi/6. This is 2 pi/6 right here. And that reduced to pi/3. However you want to look at it, you know, be my guest. But hopefully you'll start to think of pi/3 as, you know, visually, if you're to draw the angle, it'd be like drawing 60 degrees. And you'll get used to that. So this triangle is going to be our tall one right here. So it's kind of being drawn like this. Same triangle as this one, it's just up on its side now. This side right here, that's 1/2. And then the vertical side right here is going to be square root of 3/2. So cosine is your horizontal distance, which is +1/2. So our answer there, here I know it's going to bother somebody, let's write our answer in red. +1/2 is our answer. So going on to the next one, and you can pause the videos if you know you're doing one at a time and hit and play, that's fine, just pause in between. But the sine of 3 pi/4, where is 3 pi/4? Well, I know 4 pi/4 is pi. So 3 pi/4 must be 1 pi/4 short of pi. Because 4 pi/4 is pi. So it's this triangle right here. Because it is over 4, I should be thinking like, hey, it's this triangle right here. It's an isosceles, right isosceles triangle. And so it's square root of 2/2, square root of 2/2 like this. Now because it's right here, this side is negative. Not that it matters in this case because we're talking about sine, which is the vertical distance. So it's going to be this as our answer right here, positive square root of 2/2. If I was asking for the cosine of 3 pi/4, it would be the negative square root of 2/2. Let's look at the cosine of 3 pi/2. So if I draw out the circle, where is 3 pi/2? Is it bigger than pi? Well, 2 pi/2 would be pi. 2 pi/2 would be right here. That would be pi. And 4 pi/2 is 2 pi. So if you don't have it memorized, and maybe you can see it right here, or remember that, hey, at the top that's pi/2, 1 pi/2, 2 pi/2, this is 3 pi/2. So as we do these, and not just repeating and copying out the unit circle, but we think about these individually and in relation to pi and 2 pi, hopefully you start to visualize how big these angles are and where they are in the unit circle. So the cosine, remember, is the horizontal distance, which in this case you're going left to right, none, and so you're down -1, so this is going to be 0. Or let's write this out in red, 0. You can tell the little z like number 4 there. Alright, sine of 5 pi/4. First question, is it bigger than pi? Well, it is, because 4 pi/4 is pi, right? So I know right here is 4 pi/4, and it's going to be 1 pi/4 past it. Now, because it's got the 4 in the denominator, it's like our 45-degree angles here going around the unit circle. So I know I'm going to be dealing with this triangle right here, but it's actually drawn like this right here. So I'm going to restart that one. Let's start with the right angle and go like this. So I know that I'm going to the left a negative square root of 2/2, and then I'm going down a negative square root of 2/2. And so I want the sine, which is the vertical distance. Doesn't really matter because they're both the same, but to keep with our talk here, the vertical distance is negative square root of 2/2, and so that's going to be my answer here, negative square root of 2/2. One more right here, the sine of pi. So let's draw our circle. Where's pi? Hopefully you know where that is. It's right here. Sine is our vertical distance. So from the origin we go over a -1, and then we go up or down none. So our vertical distance is none, and therefore the sine of pi is 0. So hopefully this kind of helps you understand like how I expect you to do 10 of these problems in like 2 minutes, because as you practice these, you'll get faster and faster. Just like your multiplication table, you might have struggled with what's 3 times, I don't know, 7. You know, you might have struggled with that for a while, but after practice, you can say it, you know, before you think it, you know the answer before you can even say it, you know, and you'll get pretty good with these as well. So practice those. You know, you can just pull up a unit circle. This is all I did was I looked at these, I picked a few different angles and say, give me the sine, cosine. You should be able to tell me the sine and cosine of all these angles. You should be able to tell me the sine and cosine of all of these angles. And then today we're going to learn how to take the tangents of all those angles. So let's do that next. So let's start with this angle right here, pi over 6. And let's look at a few things about this triangle that we've already talked about some. If I draw it out, here's pi over 6, my angle. Up here's pi over 3. This is pi over 2. And this hypotenuse is 1. This side is 1/2. And this is what? Square root of 3 over 2. And I do my sine, cosine, and tangent values here. Now this is just going back to right triangle trig for right now. So if you're in geometry class and they say, find the sine of it, you say, okay, I know sine is opposite over hypotenuse, so it's 1/2 divided by 1, which equals 1/2. Find the cosine of it. Okay, I know it's my adjacent side divided by the hypotenuse, or square root of 3 over 2 divided by 1, which is square root of 3 over 2. But if they say find the tangent, it's not quite as easy as find the sine and cosine on this, because the hypotenuse is not in the denominator. And so you don't have a denominator of 1. But we know tangent, it's opposite over adjacent, or 1/2 divided by square root of 3 over 2. So we have a fraction divided by a fraction. Pause the video and simplify that. Alright, I know you paused the video, right? Okay, good for you. So it's keep the first 1/2, switch this to multiplication, and flip this fraction. 2 divided by 2 square root of 3 right here. There we go. Before we multiply, I can cancel out the 2's. I get 1 over the square root of 3. And then I'm going to rationalize that denominator. Square root of 3 over square root of 3. This becomes 3 in the bottom and square root of 3 in the top. So I end up with square root of 3 over 3. That's the tangent of this right here. So what it is, I took the sine value and divided it by the cosine value. Did y'all catch that? What I said there? I took what and divided by what? I took the sine value, 1/2, right here, and divided it by the cosine value. See this? This is the sine of the angle. This is the cosine of the angle. Let's rewrite this in a different format before we move further. So I told you in the last video, I don't use SOHCAHTOA. I tell my students to learn the phrase, Oscar had a heap of apples. And then say, look at your calculator, and it's written in the order sine, cosine, and tangent of whatever angle you're talking about. We'll call it theta here. And I just said I took the sine of theta and divided by the cosine of theta and got the tangent of theta. Why does that work? Well, let's try it out. If the sine of theta equals opposite over hypotenuse, and I divide it by the cosine of that angle, which is adjacent divided by hypotenuse, what do I get? Well, do the same thing we just did. Simplify this fraction. So keep it, switch it, flip it. Keep the top, opposite over hypotenuse. Switch division to multiplication, flip the bottom, and then multiply. The h's will cancel, and you get opposite over adjacent, which is, oh, it's tangent. And so this becomes one of our identities that you'll have to know later on, but if you want to know what the tangent of theta is, and you already know the sine and cosine, you can just say, take the sine of theta and divide it by the cosine of theta. And so You already know how to find the sine and cosine of a lot of angles on the unit circle. We just did that at the beginning of this video. Now you can find the tangent just by dividing the sine by cosine. So if we look back at, let's go back to here. That's too messy. Let's look right here. If I look at pi over 4 and I say, what's the tangent of pi over 4 equal to? Well, what's the sine of pi over 4? The sine is the vertical distance here, square root of 2 over 2. What's the cosine? It's the same thing, square root of 2 over 2. And so the tangent of pi over 4 is equal to 1. Don't believe me? Type it in your calculator. Say, if you're in degree mode, you say, what's the tangent of 45 degrees? If you're in radian mode, you can say, what's the tangent of pi over 4? You should get 1 as your answer. And so you should have by now filled out several of these unit circles with the angles marked and the ordered pair for sine and cosine there. And so now I want you to go through, and before I show you how to do it, I think you're capable of doing all these, is go through and find out the tangent of each angle. All you have to do is take the sine of that angle and divide it by the cosine of that angle. So in this case it was this divided by this. Right here, for 0, if you want to know what the tangent of 0 is, you say, okay, I know the sine of 0 is 0. The cosine of 0 is 1. Sine divided by cosine gives you the tangent. So this is 0 divided by 1, which equals 0. So go through, not just on this circle, but this one also. Actually, go back to, I don't know what happened to my circle there. Go back to the completed unit circle and fill out for tangent. All right, I'm going to pick it up from right here. I wrote down the angles. Like I said, if you know how to figure out these ordered pairs already, then go ahead and skip to the next part. I don't care about that. Actually, skip to the part where we find the tangents. You can check your work there. I'm going to go through and just the lines right here, they're in black. I know that they're 1 away from the center, so it's just directly to the right. It's 1, 0. Here it's 0, 1. Here I've got -1, 0. And right here I have 0, -1. So that's pretty quick. Then I'm going to go through with the blue lines there. I know that that's that triangle. It's the square root of 2 over 2, square root of 2 over 2. So this one, they're both positive. And if you skipped over the beginning of the video, then you don't know what I'm talking about probably, so go back and watch that. This is negative square root of 2 over 2, because it's the x distance. The vertical distance is square root of 2 over 2. Just don't forget there's a negative right there. This is negative square root of 2 over 2, negative square root of 2 over 2. And by the way, you can kind of think of this as quadrant 3. Everything down here is going to be negative. This, all your x values are negative, y values are positive. Everything's positive up here. X values are positive over here, y values are negative. So the y value is going to be negative right there. Our sine values are going to be negative in quadrant 4. So that takes care of the blue ones. For the green ones, I know that this is the triangle here. That's the short side's 1/2, the long side square root of 3 over 2. So this goes square root of 3 over 2 up 1/2. This one over here is going to be negative square root of 3 over 2 up 1/2 again. These are both negative, negative square root of 3 over 2, negative 1/2. And I know you can't read that, but you can hear me. And you should know this already as far as, it should just be a reminder. It's not the first time we're learning it. Square root of 3 over 2 right here, and then negative 1/2 right there. And then when it's kind of the x values, that 1/2 value, it's positive right here, negative right here, positive, negative 1/2 our x value, negative square root of 3 over 2 right here, and then positive 1/2, negative square root of 3 over 2 right there. So that's going around figuring out all those ordered pairs, which we know that the cosine is the x value, the sine is the y value. And so that's a lot of angles you should be able to find the sine and cosine to. And then we just talked about how to do the tangent. And tangents are always written in purple, so I'm going to write this one in purple. I think on your sheet that I gave you, if you still got that sheet, you're practicing. If you need an extra sheet, message me. If the teacher that's there for me has run out. I'll get you some more. Just let me know. I can get you some more practice sheets if you like doing that. Or you could probably find them online somewhere that are blank. But I think on the one I made for you, I said in the underlined spot, write the tangent value. So let's do that. I just won't write it in an underlined spot. It'll be written in purple. So I'm going to start right here, and we know that sine divided by cosine is our tangent value. So 0 divided by 1, that's 0. That's the tangent of 0 and 2 pi there, and all coterminal angles with 0 and 2 pi. 4 pi, 6 pi, 8 pi. All multiples of 2 pi. If you take the tangent of it, it's going to give you 0. Going on up, we'll go through and do each individual angle. 1 divided by 0 over here. What's 1 divided by 0? 1 divided by 0. Oh, you can't divide by 0. So the tangent right there is going to be undefined. So this guy is undefined. Over here at pi, the tangent of pi, 0 divided by negative 1. Well, that's 0. So that tangent is 0. Negative 1 divided by 0 down at 3 pi over 2. That's going to be undefined again. And so those, again, you should be able to look at and tell really quickly. And I'll show you a shortcut on all these once we get done, reviewing that whole sine divided by cosine type thing. Now, for this one, actually, let's do the blue ones next because they're pretty easy. We did this one earlier. Square root of 2 over 2 divided by square root of 2 over 2. That equals 1. So 1 is our tangent there. So the tangent of pi over 4 is equal to 1. Over here, I got a positive square root of 2 over 2 divided by a negative square root of 2 over 2. That's going to be negative 1. So the tangent, well, I don't really need to write over 1. Just negative 1 will be fine. I feel like I'm writing a fraction bar when I draw that underlined thing there, so I'll just write it like that. So I can say that the tangent of 3 pi over 4 is negative 1. For 5 pi over 4, this is same thing, square root of 2 over 2, or negative square root of 2 over 2, divided by negative square root of 2 over 2. That's a negative divided by a negative. It's going to be a positive 1. So that's a 1 right there. I'm just underlining it because I think the worksheet I gave you, there's an underline there. And then lastly, this is a negative divided by a positive, which is going to give me a negative 1 right there. Now all I got left are the green angles. So let's talk about those green angles. I want to write it out here on the side. If I take sine 1/2 divided by square root of 3 over 2, that's not me making all those noises, that's my baby I'm holding right now. But if I take and divide that out, keep it, switch to multiplication, flip this, that gives me 1 over square root of 3. We just did this a second ago. Rationalize the denominator, and I get the square root of 3 over 3. So that's going to be this one right here. Now go through and look and see what other ones do I have 1/2 in the y spot, or negative 1/2 in the y spot, and square root of 3 over 2 in the x spot, or negative square root of 3 over 2 in the x spot. Well, I've got it on these shallower lines. Notice this line is shallower than this as far as the steepness or the slope of it goes. So if I go over to the left here at 5 pi over 6, I've got 1/2 divided by square root of 3 over 2 again, except for this time the square root of 3 over 2 is negative, which means it will give me the same result, square root of 3 over 3, but because it's a positive divided by a negative, I'll get a negative value there. So this is going to be negative square root of 3 over 3. Same thing down here. I get the same triangle, same y and x values, except for they're both negative, and a negative divided by a negative is going to be a positive. So it's going to be positive square root of 3 over 3 for my tangent value. If I look at 11 pi over 6, same values there in the x and y spots, except for the y value is negative, the x value is positive. Negative divided by a positive is going to be a negative. So it's going to be negative square root of 3 over 3. All right. Probably sounds like I'm holding a puppy, but I promise it's a baby, not a puppy. If I was holding an animal, it would be a cat, because cats are better than dogs anyway. So let's look at pi over 3 now. So pi over 3, let's practice dividing that out. I'm actually going to clear a little room over here by erasing this. And so I've got square root of 3 over 2, that's the sine of pi over 3, divided by the cosine of pi over 3, which is 1/2. So we're going to keep it, switch to multiplication, and flip. 2's cancel. I get square root of 3 over 1, which is square root of 3. That's a nice one. You don't have to rationalize anything. So once again, I've only got a few angles left here, and they have the same x and y spots there, except for some are negative and some are positive. So this one, I got a positive divided by a negative. That's going to give me the same thing as this, except for it's going to be a negative answer. So a negative square root of 3. Make sure that negative's on the outside of the radical. Down here, I know it looks like a smudge of whatever this digital ink stuff is. It's the same spots, except for they're both negative. And so it's going to give me a positive square root of 3 right there. And then I've got one more. Where is it? Right here. This is going to be a negative square root of 3. Now go through, look at your tangent values written in purple there, and tell me what possible answers can you get for tangent. Now those possible answers are going to be written in red. We have sometimes our tangent comes out to be 0 right there. Sometimes it comes out to be 1. Sometimes it's the square root of 3 over 3. And other times it's square root of 3, and then it can be undefined. And it could be positive or negatives on these also. Those are the only options for tangent as far as our common angles on the unit circle go. Now, obviously, if you go outside of those angles and pick other angles in between, you'll get different tangent values. But if you had to guess on a quiz, I mean, it should be one of those answers if I'm asking for tangent. Don't guess, though, because this stuff, you're all capable of figuring it out. Now, the next thing I want you to think about is this. Let's think back to, I don't want to quite give it to you yet. Let's look at, I'm trying to pick the right color. I've used purple, green, blue, I've used all the colors. I think, oh no, I got a whole list of options here. I know you're tired of watching. Just pick a color, Mr. Burnett. Let's go. Let's do bright green. So, if I look at the value, let's just look at this line of pi over 6 here, or the angle pi over 6. If I talk about going from this point to this point, think about the steepness of that line. It would be going from that amount of run and that amount of rise. Right? So what is that run? That run is square root of 3 over 2. What's the rise? The rise is 1/2. So what's the slope of this line right here? Well, the slope is rise over run. 1/2 over square root of 3 over 2. Divide that out, rationalize it, you should get the square root of 3 over 3. Oh, wait a minute, that looks familiar. That's the tangent. Is the slope always the tangent? Try it out on another one. Well, you could try out, here, let's pick a different color here. We'll pick red. What about going from this point to this point? What's your rise? Your rise is none. What's your run? Your run is 1. What's 0 divided by 1? Oh, it's 0. What do you know? It's the tangent of that line. Or the tangent of that angle, excuse me. Slope of that line, tangent of that line. Look at the blue angle right here. What's your rise over run? Let's pick dark blue for that one. So I'm going to run this way, and then I'm going to go up, pretend like that's a vertical line. So my run is square root of 2 over 2. My rise is square root of 2 over 2. Rise over run, square root of 2 over 2 divided by square root of 2 over 2. That gives you positive 1. So the slope of this line right here is 1, and so is the tangent. The tangent's also 1. Well, let's follow this line down. Follow that line right here all the way down to this point. Now from here to here, the diameter of the circle, it should have the same slope, right? Guess what? That tangent value down here is the same as going up this line and to that point right there. Let's spin it around. Look over at this blue line. Same triangle. You go to the left, square root of 2 over 2, and up square root of 2 over 2. So your rise is square root of 2 over 2. Your run is negative square root of 2 over 2. You go from here to here. You could go this way also and say it's a positive run and a negative rise. And you get rise over run, you get a -1, which is negative slopes go downhill left to right. If you follow that line down, this point right here also has a slope or a tangent of -1 because it's on the same line, same slope there. So the interesting thing here is we're starting to see that the slopes of these lines are the same as the tangent because it's rise over run, and your rise is your sine value and your run is your cosine value. Now how does that help me? We'll go back to these possible values right here. Ignore undefined for a second. I think most of you can look at this. Look at the undefined spot. What's the slope of a vertical line? Oh, it's undefined. And that's what your values for tangent are at pi over 2 and 3 pi over 2. So ignore undefined for a second, and I want you to put these in order from largest to smallest. No, not largest. Smallest, let's go smallest to largest. So while you do that, you can pause the video if you want. I'm going to just clear up some space. Alright. Now, pause the video if you haven't gotten the answer yet. I'm going to write it out. So we know that 0 is smaller than any of those positive numbers. We're just wanting to get the positive values here. Is 1 bigger than the square root of 3 over 3? Yeah, 1's bigger than the square root of 3 over 3. Is it bigger than the square root of 3? Type in that value in your calculator. See what you get for the square root of 3. What's the decimal approximation? Well, let's look at it. We got square root of 3 gives me 1.73. So 1's not bigger than square root of 3. What about square root of 3 divided by 3? So divided by 3 gives me 0.57, close to 0.6. So 1 is bigger than square root of 3. So let's go back to this spot right here. I know that 1 is larger than the square root of 3 over 3, so going from smallest to largest, we got square root of 3 over 3, 1, and then square root of 3. Now let's just look at quadrant 1 right here. Think back to what you know about slopes of lines. Let's just erase all this mess in the middle here. If we're talking about slopes of lines, which is steeper, a slope of 1/2 or a slope of 1/4? Well, a slope of 1/2 means you rise 1 and run 2. So if you're talking about a grid here, you go up 1 over 2. A slope of 1/4 means you rise 1 and run 4. So this thing is going to be much shallower than 1/2. I know it's kind of tiny if you're looking on a cell phone. Hopefully you're not looking on the cell phone. But think about it as a slope of 8. What does a slope of 8 look like? A slope of 8, right as a fraction, means you rise 8 way up here and then run 1. So a slope of 8 would be a steeper line. So all in all, this is how I want you to think about these. The larger the slope, the steeper the line. All right? And notice our order. Square root of 3 is the largest. 0 is the smallest. So you go 0, square root of 3 over 3. No, 0. Oh, here's our order right here. 0, square root of 3 over 3. 0, square root of 3 over 3. 1, square root of 3, and then undefined. So it's in that order right here it goes around. But I don't want you to memorize that order. What I want you to think of is this. I know that the blue lines are either 1 or -1. Notice going this way, it's uphill left or right. So it's 1 here and it's 1 here. When I ask you what is the tangent of 5 pi over 4, first do that little circle. Down here's 5 pi over 4. Oh, I know it's over 4, so it's one of the 45-degree angles. And then it's going uphill left to right, so our slope is 1. And so the tangent is 1 at 5 pi over 4. 3 pi over 4 and 7 pi over 4, it's -1 because it goes downhill left to right. We know that if it's completely horizontal, our slope is 0 and 0. If it's completely vertical, our slope is undefined and undefined there. Whoops, move the whole screen. So those should be, quick ones to get. The 45-degree angles, horizontal line, vertical line. Pretty easy slopes to come up with. Now the ones students tend to get a little tricky on are square root of 3 and square root of 3 over 3. Just remember this. Which one's bigger, the square root of 3 or the square root of 3 divided by 3? I think something is going to be larger if it's not being divided by 3 already. So the square root of 3 is a larger number than the square root of 3 divided by 3. So the square root of 3 is the steeper slope. So looking at this line, comparing it to this one's steeper. So that's where our square root of 3 is. Follow it down. Notice still, this line is steeper. This one's shallower. This one's going to be our square root of 3. Since these are shallow lines, they're square root of 3 over 3. Since they're going uphill left to right, they're the positive ones. Same thing over here. This one, I'd rather be, if I was falling down a hill that I didn't want to fall down, I'd rather be falling down this hill than this one, because this one's super steep. So because it's steeper compared to this one, it must be the square root of 3 one. Because it's going left or right downhill, it's going to be the negative square root of 3. Same thing down here, it's negative square root of 3. This one right here connects to this guy right there. This one's shallower, so it's going to be the one with square root of 3 over 3. Because it's going downhill left to right, it's going to be negative square root of 3 over 3. All right? So all in all, that's tangent. All right? Tomorrow we'll start off some with a little bit of practice on all of them, mixing in tangent and sine and cosine, and then we'll get into the next topic. But your job today was to take notes, and I know you had to pause the video some, so you're probably about out of time. You can still finish it up for homework if you haven't done it. If you've made it through 52 minutes of listening to me talk again through a set of headphones, good for you. I'm hoping it's benefiting you some to see this and to try it. It is harder to do it this way in the beginning than just memorizing it, but it will be more meaningful to you, and you'll remember it for life. No, you may not remember it for life, but hopefully you'll remember it through next year. And if you go into a math field, I do hope that you memorize it for life. You know, not memorize it, but understand it for life. But anyway, hopefully this helps, and thank you for working hard.